Hello, my name is Manuel Sierra and welcome to this MOOC on antennas. Today I'm going to explain some basic aspects about design criteria in far-field antenna measurements. This session is included in the antenna measurement unit of this MOOC. The objective of this session is to explain, as I mentioned, the design criteria for far-field antenna measurement systems. I divided this session in mainly five characteristics or 5 criteria. The first one, we say that we are in far-field when the inductive coupling between two antennas, antenna under test, antenna prof, is low enough. That means that you have to be enough far, at least 10 times the wavelength, to consider that for this is the field created by the short dipole is low enough. So these components are much lower than these main components. And you get this condition when you get at least this distance. Basically, this is important only for low frequencies. The second criterion. In far field, you are supposed to be in an open area. You cannot have any reflections from anywhere. You have to avoid reflection from the environment, here or here, placing observers or placing fences or whatever, but also you have to avoid multiple reflections between both antennas, antenna under test and antenna prof. You can get this with good matching of your antenna prof and placing absorbers in the metallic supports, towers, masts, and so on. The third criterion is the longitudinal variation of the amplitude in the antenna under test. This is important for long antennas. In this case, you can see in the figure that, as you see, the amplitude of the field in this place should be the same than the amplitude of the field here. If the antenna is very long with respect to the radial distance, this our distance, maybe you are not getting or accomplishing this criteria. Of course, in outdoor ranges, this is not a problem, but we will see later that we can get far-field conditions in indoor ranges, in anechoic chambers, for some specific frequencies. And maybe you can have some problem with this. Basically, the condition is that the radial distance should be larger than 10 times the length of the antenna under test. The next criteria comes from the amplitude taper of the illuminating wavefront. In this figure, you see the radiation pattern of the antenna source impinging on the antenna under test. As you can see here, the field here from this antenna prof is higher than the field in the edge of the antenna under test. If you have this, you are creating some error in the measured field. So you have to bound this difference. Typically, if you have this bound, you have an error in the gain of minus 0.1 dB. That used to be good enough. This is also important for measurements in indoor runs when you are in far field. And the most important specification is this one. It's the phase curvature of the illuminating wavefront. As you can as you can see here, when the field impinges in the antenna under test, there is a difference of distance between this point and this point. This distance error creates one phase error. Normally, the far field criteria says that the maximum phase error you can have in the worst point in this area is 22.5 degrees, or pi divided by 8. And this is obtained when the radial distance accomplishes these equations, 2d squared divided by the wavelength. And this used to be the main parameter in indoor and outdoor far field ranges. Here we have a graph for different frequencies, for different dimensions of antenna under test, and in this axis we have the far field distance. For instance, for 900 megas, 1 meter antenna, you can have far field at 4 meters or 5 meters. However, for 100 gigas and 10 meter antennas, you need some kilometers. Obviously, you can measure in an indoor range this antenna, but for measuring this antenna, you need big, large outdoor ranges or special systems. Basically, depending on the frequency and dimensions of the antenna under test, you have to be sure that you are in far field. If not, you have to measure in a different way. Finally, you can find here some references. I recommend you the IEEE standard test procedure for antennas, antenna measurement techniques from Evans, and microwave antenna measurements from Scientific Atlanta. Thank you very much for your attention.